Assalamu alaikum. Today we are going to discuss about another type of stereo isomerism. Last time we have discussed about geometrical isomerism. Hope you can have clear understanding about that topic. Now we are going to discuss about optical isomerism, which is another important type in pharmacy, or obviously for the chemistry students as well. Optical isomerism. Actually, it is a type of stereoisomerism in which an optically active compound can exist in two isomeric form, which rotate plane polarized light in opposite direction. So these are called optical isomers, and this phenomenon is known as optical isomerism. So do not worry, I will explain you in detail these things. Just write it down, the basic description, basic definition or basic introduction of the optical isomerism. That is, let me write here. It is a type of stereoisomerism in which an optically active compound can exist in two isomeric forms, which rotate plane polarized light I will definitely explain these things in this lecture. In opposite direction. So this phenomena is known as optical isomerism. I hope now you can understand this. So before going to discuss these things, we have some terms which are need to be discussed here, so you need to have a clear concept about this. So in this whole definition, there are three main concepts actually are there. One is plane polarized light, second one is optical activity, and third is plane of symmetry. This is actually the main part, to need to have a clear concept about this. So in order to understand the optical isomerism, so let's start with plane polarized light. So the first one is plane polarized light. What is the concept of this over here? Plane polarized light. Actually, when we see, or you can say, light from ordinary electric lamp, is composed of various waves which are vibrating in many different planes. different planes. Say for example, this is the plane of light. So light can have various waves, like something this. It can vibrate something like this. It can vibrate like this. It can vibrate like this. It can vibrate like this. So this is an ordinary light. And what do we mean by plane polarized light? So whenever this light is passed through some kind of prism, let's suppose nickel prism, that is composed of calcium carbonate. Okay. So in order to this ordinary light, when passes through this prism, here is, you can place the prism. So it causes the light is vibrate, move only one direction, something like this. So now this is called polarized light or plane polarized light. I hope you understand what is the plane polarized light. When ordinary light pass through the nickel prism or any prism particularly made of calcium carbonate, this make plane polarized light, which is vibrating only in one direction. Clear? So this is the condition, or this is a requirement for assessing the optical isomerism of any compound, whether it is optically active or not. So you have to make plane polarized light, and you cannot confirm the optical isomerism from just ordinary light. Okay, now we have ordinary light, optical activity. That is the second part which is necessary to discuss. Optical activity. So some organic compound have the ability to rotate the plane of polarized light. So these compounds are said to be optically active, and this property of compound is called optical activity. So I'm again explaining. After explaining this polarized light, in organic chemistry we are having some organic compounds. Some organic compounds have the ability to rotate the plane of polarized light. To rotate the plane of polarized light means this is the plane polarized light, so it has some organic compound have the ability to rotate the plane of polarized light. Means let's say it is in 90 degrees, so some organic compound have the property that they can rotate to here or here. We will discuss in later. So for now, just understand some organic compounds have the ability to rotate the plane of polarized light. So these compounds are set. So these compounds are said to be optically active compound. And this property is called optical activity. So I hope now this makes sense. I am again explaining about optical activity. It is actual property of some organic compounds organic compounds, not all organic compounds, some of the organic compounds have the ability to plane the rotate of polarized light. I am explaining rotate the plane of polarized light. So it has the ability that it can rotate this plane of polarized light. So these compounds are said to be optically active and compound, and this property is known as optical activity. So how to measure this optical activity? Optical activity of a compound optical activity of a compound can be measured with the help of an instrument called polarimeter. So how this polarimeter works? Here is the explanation of this polarimeter. When a solution of known concentration of an optically active compound or material is placed in polarimeter, then the beam of polarized light is rotated through a certain number of degree, either to right, which is also called clockwise, or to left, which is also called anti-clockwise. So I am again explaining. Optical activity of the compound can be measured with the help of polarimeter. How this polarimeter works? When a solution of known concentration of a optical active compound is placed in polarimeter, the beam of light is rotated through a certain number of degrees. Means this plane of polarized light, this can be rotated through right or to the left, clockwise or anti-clockwise, with some degree. So it explains that this compound has optically active property, or a compound is optically active. Okay, so I am explaining again. Let's suppose it is a light source. It is an ordinary light source. So it has something like this. The bands or the waves are something like this. It has this vibration, maybe this vibration, maybe this vibration, and maybe this vibration. So when this light is passed through some kind of prism, earlier we have discussed already, prism, it become polarized light. How? Something like this. When this plane polarized light or the polarized light is passed through we are talking about the sample of organic compound which is optically active. So this is an organic compound sample. Organic compound sample. Then this compound has the ability or the property to rotate the plane of polarized light either to the right or to the left. So it will become something like this. So as we can understand that this compound rotates the plane polarized light to the right side, so we term this as dextro, or clockwise or anti-clockwise left. So now we have to understand what is dextro rotatory. Dextro rotatory, also called positive compounds or clockwise compound. So now understand this: the compound which rotates the plane of polarized light. The compound, this is the compound which rotates the plane of polarized light. It is in, let's say, in static condition. If this compound rotates the plane of polarized light, I'm emphasizing on plane of polarized light, means this is the plane. It rotates to the right side, clockwise side. It is called dextrorotatory compound. It is indicated or denoted by positive sign. Okay, and if the compound is rotated to the left side like this, it is called levorotatory. It is indicated by negative sign, or it rotates the plane of polarized light counterclockwise or anti-clockwise. So I hope this optical activity now you people can understand. Now we will discuss about the third very important concept, which is called plane of symmetry. It will come when we will discuss about enantiomers or conformations. Plane of symmetry. For now, just understand about this concept. Actually, plane of symmetry is a plane which divides an object into two symmetrical halves. Is said to be plane of symmetry. A plane which divides an object into two symmetrical halves. Is said to be plane of symmetry. Say for example, hat or a person. So it means whenever we divide something into two objects, into two parts, if it is completely, you can say, divides on equal terms on the both sides, then it is known as plane of symmetry. But on the other hand, if a person, let's say for example, we have given a hat example. If we cut this hat into a two portion, so half is there, so that's okay. Let's say another example of hand. So you might know that you can see your hand as well. Hand of the person lack a plane of symmetry. It does not have plane of symmetry. Why? I'm trying to making hand like we have 1, 2, 3, 4 and 5. So you can see, if we try to half or cut it down this hand into the two halves, you can see it will not be able to divide equally. So So this compound lacks plane of symmetry. Hope you can now understand this symmetry. So what does this mean? So those compounds which are lacking plane of symmetry is called chiral compound. So those compounds which lacks plane of symmetry is called dissymmetric or chiral compounds. I hope this makes sense now. So what is the opposite of chiral? It means the compounds which have the plane of symmetry is called achiral. So I hope this makes sense now. I'm again explaining these things again, so keep in mind again. We say plane of symmetry. It is a plane which divides an object into two symmetrical halves, or you can say identical halves, is said to be plane of symmetry. Like we are giving example of hat. When we divide this hat into two parts, it is identical to both parts. Then we give example of hand. It lacks plane of symmetry. What does this mean? That look at your hand, and if you try to divide into two equal halves, it cannot be. Either 3 fingers or 2 fingers are on one side and 3 fingers or 1 toe with on the other side, so it cannot be equal. So those compounds which lack plane of symmetry is called dissymmetric or chiral compounds. Chiral, okay. And those compounds which have the plane of symmetry are called achiral compounds. Like this is achiral. I hope now this makes sense. So in optical isomers, we are having two isomeric forms. One is called plus, as discussed earlier, or dextrorotatory isomers. Second is negative sign, that means levo-rotatory isomers. So the optical activity or the rotatory power of two isomers are equal in magnitude. Equal in magnitude means plus minus can cancel the sign, but in opposite in sign. So an equimolar mixture of two isomers therefore will not rotate the plane of polarized light as all and is said to be racemic mixture. So actually I am discussing about the third type, which is called racemic mixture. What is racemic mixture? An equimolar, equal concentration, having equal molarity, equimolar mixture. What does mean by mixture? Having two things of two isomers, mixture of two isomer, therefore will not rotate the plane of polarized light at all. And so this is called racemic mixture. I am again explaining you an equimolar mixture of two isomer. What does this mean by two isomers? I am talking about this and this, two isomers, that is plus minus. Alone this is dextrorotatory, alone it is levorotatory, but when we make a combination of these compounds, it is usually called as racemic mixture. So racemic mixture will not rotate plane of polarized light at all. So any compound which is have the ability or an optical activity or optically active compound but cannot rotate the plane polarized light, so you people know that it is a mixture and it cannot have the ability to rotate the plane of polarized light. So I am giving you example. Consider the example of this: carbon, hydrogen, COH, CH3. Consider is at as positive. Positive means dextrorotatory. Let's consider the example image A number A. Then we have image number B. We have carbon, we have hydroxyl group, we have this hydrogen, we have this carboxylic group, we have this methyl group. So consider it as negative. And then we have a mixture, like we have discussed about equimolar. Mixture, whenever we have mixture of two forms, we know that either it is positive, negative, both. So consider it as third. Actually this is example of lactic acid. This compound is lactic acid. It is positive, so it means it is dextrorotatory lactic acid. It is levorotatory lactic acid. And when we talk about the racemic mixture of lactic acid, so lactic acid positive means it has the ability to rotate the plane of polarized light to the clockwise or to the right direction, and negative means it is a lactic acid which has the property to rotate the plane of polarized light to the left side, something like this, and this is called racemic mixture. It do not rotate the plane of polarized light. It is optically inactive. I hope this makes sense and you people can understand this clearly. So actually, as we discuss about stereochemistry, so how these things are gonna happen, we know that this is the central carbon atom. We have this hydroxyl group, we have this hydrogen here, and we make it something like this, like you people see in the books. It is written something like this. So what does this mean? This is CH3 and this is in dashed lines, this is carboxylic group. So that shows it goes back, means in stereoisomerism I am talking about 3D structure, and this comes forward. So whenever you see something like this sign, it means that it is in front of the plane, in front of the paper, and this is the goes beyond. So I hope this makes sense. So now, as we have discussed many things, now we will go for optical isomerism condition. That is very important, how optical isomerism are formed and when they are not formed. Okay, so now we are discussing about conditions. Optical isomerism. The first one is molecules. You can write here molecules should be dissymmetric. Dissymmetric means this compound should lack the plane of symmetry, like we have discussed earlier. Molecule should not be superimposed. I will tell you about what does this mean, molecule should not be superimposable. Should not be superimposable on its mirror image. Okay, so molecule should be disymmetric. I told you earlier that molecule dissymmetry also called chiral or having no symmetry, and molecule should not be superimposable image. So what does this mean? Let's consider about this image. Image number A, we are having this carbon. Okay, let me correct it. We are having this carbon. We are having this A compound here, B here, C here, and D here. Here is the mirror, so it will form image like this. We are having this carbon here, so we are having this compound A here, we are having this D here, we are having this B here, and C here, C here. So you can see the plane, they are so non-superimposable, means when you try to put the one thing on another, if it fits actually or it fits fully 100%, so it called that this is, you can say, superimposable. But if these images, you can consider that if you are taking this C, like here, let me explain. If you try to impose one on each other, mirror images of each other, so we know that C is here, okay, C is here in place of D here, but in this image D comes here, so it is clearly explain you that these are not superimposable images. So it is a criteria or condition for isomerism that these should not be superimposable, means they have to be on the other sides. If they are on the same side, they are not called dissymmetric compound. Okay, so we can say that B is the mirror image of A. We know that, but they are not superimposable. Okay, so what this means, that mirror images and non-superimposable. So remember these: non-superimposable images, mirror images, forms chiral. Chiral means having lack of plane of symmetry, are called enantiomers. Enantiomers, like we are having example of lactic acid. Let's say this is CHOH, COOH, and CH3 mirror. Then we are having OH, H, COOH, CH3. So we term this as enantiomers. Those compounds which are non-superimposable mirror images of each other are called enantiomers. So this enantiomers is the first type of your optical isomers. I hope this makes sense. Actually I forgot to mention in start. I should have mentioned in start that optical isomers are of two types. One is enantiomers and second is distereoisomers. So I hope this makes sense. Now we will talk about the second type of the optical isomerism, that is distereoisomers. Distereomers. And this is actually another type of optical isomers. And optical isomers, we have discussed about enantiomers in previous lecture. Now this is the second type, that is di-isomers. Let me write about this. There are certain situations in which molecule do not possess mirror images. Although it contains asymmetric carbon. That means if it is having asymmetric carbon, it is non-superimposable images are there, mirror images are there, but still they are not mirror images, which do not possess mirror images. How? So this type of the situation, or the situation which arises, this type of the compound are called diastereomers, which is an second type of the optical isomers. Let's say for example consider the example of 3-bromo 2-butanol. CH3 Br CH3. Consider it as A. One condition is this: we are having this CH3, this carbon, hydrogen, hydroxyl group, we are having this hydrogen, we are having this bromine, we are having this CH3. Consider this image B. Let's say we have another example, because of 2 chiral carbon are there. CH3, we are having this OH, we are having this Br here, we are having this hydrogen, we are having this CH3. Another example is now consider it as example number D. Now you can see here are 4 different images. Consider A and B, C and D. They are mirror images. Like we have this bromine here and this bromine here, this hydroxyl group here, and this is here. So these are mirror images of each other. Similarly in condition number C, so OH is there, so they are mirror images. Bromine is there. Okay, so we can say according to these images, A is mirror image of B. Mirror image of B. Similarly, C is mirror image of D. But now compare A and C. Just compare A and C. Here you can see this is your CH3 COH. Let me write some, it will be easy for you people. CH3 OH H Br CH3, it is A, and when we compare it with C, what is the C image? It is CH3 OH H C Br H CH3, it is C image. Now you clearly understand A and C are neither superimposable image nor their mirror image, so this compound are called diastereomers. Mean. Now look at this, CH3 same, CH3 same, OS same, OS same, till now it is okay. But when we look about bromine and hydrogen, so bromine on the other side and here bromine on the other side, so means if they are not superimposable image of each other. If this compound is this compound is not the same. Here OH and hydrogen lies on the same place, but here bromine and hydrogen do not lies on the same place. So these sort of the images are called diastereomers. I hope it makes sense now. The compounds which are neither superimposable image nor their mirror images of each other are called diastereoisomers. Okay, and last we are having mesocompounds. A compound with two or more asymmetric carbon but also having a plane of symmetry is called mesocompounds. So just remember, compound with two or more asymmetric carbon atoms but also having a plane of symmetry is called mesocompound. Say for example, CH3 OH hydrogen OH hydrogen CH3. Now if we divide into like this, you can see it has four different atoms, but also having a plane of symmetry. If we divide this compound equally, so that means this compound is another compound, this is another compound, but both have the same atoms. Okay, similarly we have this compound known as 2,3-dihydroxy 2,3-dihydroxy 1,2,3,4 butane. So its compound is 2,3-dihydroxy butane, meso 2,3 dihydroxy butane. Consider another example. This is OH, this is OH hydrogen. We are having this carbonyl. No, this is not oxygen. This is hydrogen. This is carbonyl. This is carbon. This is carbonyl oxygen. So this is called 2,3-dihydroxysuccinic acid. So when we divide in equal parts, so it will divide into two equal half. So thank you very much for watching this video. I hope this makes sense. If you have any confusion or question, you can ask me. I am Akil Nasim signing off, and we will be coming up with our next video, that is resolution of racemic mixture. Thank you. Allah Hafiz.